Hi there. Welcome to the second video lecture on the environmental chemistry. I hope you people are doing fine and are safe. So, for today, we are going to take a look into the atmospheric pollutions. Okay, so what do we mean by an atmospheric pollutions? What are the different types of pollutants? How they react? And what are the damaging causes? We need to study those. Okay, so as we start with the atmospheric pollutions. Now, this particular term, atmospheric pollution, refers to the two important regions of atmosphere, and those are the troposphere and stratosphere. Okay, now, among these two regions, it is the troposphere which is quite very important for us because most of the component of life stays in this particular tropospheric region. Correct. And this particular tropospheric region has a cover of the gases. Now, anything that we add into this particular region, any unwanted substance, which is going to affect, this particular thing is going to affect the quality of environment, which affects the quality of life, which affects the quality of plants, which affects the quality of the other animal life. So therefore, any unwanted substance that is added, okay, that is added into the tropospheric region is nothing more than a major pollutant which affects the life, which affects the quality of the environment. Such kind of substances, of course, they are going to be considered as a pollutant. Among these, we will study the first one, and that particular first substance which we end up adding in our day-to-day life is nothing more than a carbon monoxide. Okay, so first thing that you need to understand is the carbon monoxide is one of the fatal means deadly. Okay, it is one of the most fatal pollutants that has been added into atmosphere. There are many reasons for that. Okay, now first you need to understand that this carbon monoxide is colorless, alright, is odorless. I do not know who has going to taste it, but it is a tasteless gas. I don't know who is going to taste that. If they say it is a fatal one, dangerous one, and they are going to taste it. Quite ridiculous. Now, carbon monoxide, one of the most fatal pollutants that has been released, that keeps on releasing into the atmosphere because of the human developments. Secondly, we need to understand that it is a colorless, odorless, and tasteless gas. Okay, so first thing that we need to know is how is this particular carbon monoxide is formed and how it enters into the atmosphere. Now, most of the time, the carbon monoxide enters into the atmosphere or it is formed due to incomplete combustion, or you can also say as the combustion in limited supply of oxygen. Alright, now first let's try to understand what is a complete combustion or what is a combustion in the good amount of supply of oxygen. Okay, now let us take into consideration of one simple hydrocarbon, that is the butane. Okay, so we have a butane, and if I want to burn this particular butane down, this butane would require oxygen. Now complete combustion, in a sense, all the carbon what I have in butane is going to get converted into carbon dioxide. Complete combustion. Alright, so it is going to give me carbon dioxide and plus it is going to give me water. Now, how many carbons do I have here? 4, right? So I will take it over here as 4 and there are 10 hydrogens. I would like to take it here as 5. Okay, so 5 into 2, 10 hydrogens over here, 4 carbons over here, perfectly done. So 4 into 2, 8, 8 plus 5, 13. So 13, I would like to give it as 3 by 2. Now, sorry, 13 by 2. 13 by 2 is nothing more than 6.5 moles. Right? Now, that means in order to oxidize or completely burn this particular butane, combust it out, okay, I would require 6.5 moles of oxygen, right? Now, instead of 6.5 moles, if I just supply 6 moles of oxygen, now here I am hindering, here I am seeing that the oxygen supply is going to be less. Okay, so in case if I am going to see that I am not going to supply the 6.5 moles, rather I am going to supply 6 moles of oxygen. So that time, what is going to happen now is C4H10 is going to react with 6 moles of oxygen. When it reacts with 6 moles of oxygen, out of 4 carbons, 3 carbons are going to get completely oxidized to carbon dioxide. 1 carbon what you have, it is going to get converted into carbon monoxide. And of course, 5 moles of water you are going to get. Okay, there is no problem with that. Now here, carbon monoxide is formed. This carbon monoxide is formed because of the incomplete combustion, or I would say as combustion under the presence of limited supply of oxygen. Okay, so this is how carbon monoxides are usually formed. Now, the problem now you need to know is how is this particular thing harmful? Okay, now first point is carbon monoxide is not harmful for plants. I would repeat the statement again. Carbon monoxide is not harmful for the plants, but it is deadly for the humans. Now, why? Because if we start breathing carbon monoxide, it has a very good tendency in order to react and in order to attach with the RBCs. In the RBCs, it is going to attach to hemoglobin. Okay, so it has a direct relationship of attaching with the hemoglobin. Okay, and it attaches 200 times much more faster, 200 times much more easier, I would say, when we compare to that of oxygen. Okay, so therefore, what is happening here? It is affecting or it is attaching with hemoglobin almost 200 times. Okay, 200 times ready with the hemoglobin. So when it attaches with the hemoglobin, what is going to happen is the tendency of the hemoglobin to supply oxygen to various parts of bodies, that is going to be hampered. If that hampers, body becomes oxygen starved. Okay, so it is directly affecting hemoglobin, so it is making the body starved of oxygen. Okay, so when it happens, if you have inhaled carbon monoxide to a particular level of 100 parts per million, okay, 100 parts per million, if this is a concentration, then a person is going to have problem in breathing. So here it is fine, absolutely fine, no problem. Okay, but if the concentration goes on increasing, okay, if it increases to almost up to 750 parts per million and above, so here is a particular point where the person starts feeling very uncomfortable. It makes him so uncomfortable that the entire body becomes oxygen starved, and then the person develops anoxia. Okay, when he develops anoxia, there are two possibilities. Either the person enters into a state of coma or a person dies. Okay, so this is how carbon monoxide reacts with hemoglobin in order to make the entire body starved of oxygen. If this particular inhalation of carbon monoxide is to 100 parts per million, then there is a problem with the breathing. If the concentration exceeds up to 750, then the person develops anoxia, and this anoxia may result into death or coma. Okay, so here this was all about the carbon monoxides. Okay, now let's see with respect to the hydrocarbons. To begin with the next type of pollutant, and that is going to be the hydrocarbons. Okay, so many of the hydrocarbons in the form of the gases are already present in air, most of them. And these pollutants are usually, of the lower molecular mass. Okay, these are usually of the lower molecular mass gases, or you could say that are easily volatile liquids. Okay, now due to this, what is going to happen now here is that these particular gases or the liquids, they enter into the atmosphere. They affect adversely to the quality of the environment. Okay, so basically, if we see that, we need to understand its sources. Okay, now when we observe the sources, there are two types of sources through which the hydrocarbons are entering into the atmosphere. First one, that is going to be due to the natural causes, or I would say as a natural sources. And the second source is nothing more than like a human developments or due to the human resources. Okay, now when we take a look into these natural sources are such as the paddy fields. Okay, so the paddy fields contribute a large amount of hydrocarbons into air. Okay, so as the marshy places. Okay, so what we have is the marshy place, the paddy fields, and also animals. So the animals also contribute a lot to these particular gases. Okay, while when we take a look into the anaerobic decompositions which are occurring in the soil or sediments or water bodies. Okay, so even these anaerobic decompositions of organic matter, they also contribute to the hydrocarbons in atmosphere. Now when we take a look into the human sources, okay, so from the human sources you need to understand that 15% of the entire hydrocarbon in the atmosphere, it comes right from the internal combustion engines which are present in the automobiles. Correct. So you need to remember this point, that is 15% of the hydrocarbon in air is because of the internal combustion engine. Okay, so these internal combustion engines have a direct effect on the environment by releasing a large amount of hydrocarbons. Now, on the other hand, it is also because of incomplete combustion. Now, incomplete combustion of what? Fuels. The fuels which are used by these internal combustion engines. Okay, so in short, incomplete combustion of the hydrocarbons or of the fuels. Okay, so which are of course used by the internal combustion engines. The next point that you need to understand is of this particular sources is by combustion of coke, coal, etc. Further, there are certain ways in which these hydrocarbons escape into the environment, and that is by the state of evaporations. Evaporations of organic compounds, of organic solvents such as benzene, toluene. Okay, so evaporation of organic solvents. So organic solvents such as the benzenes. Now I am not speaking over here with respect to a smaller amount, I am speaking with respect to a larger amount in the industrial areas where usually benzene or the toluene is used in the manufacture of paints and varnishes. So that is where these particular solvents are going to get evaporated into the air. Okay, once they get into air, of course, it is going to again react and it's going to be a pollutant. Okay, now let's try and understand all about its harmful effects. So when we take a look into a lower concentration, let's begin with the lower concentration. At the lower concentrations, hydrocarbons have no effect on humans, but it have an adverse effect on the plants. Now, when this particular concentration, when the concentration is almost like 500 ppm, that is parts per million, to 1000 parts per million. Now, here is where the actual problem starts. Here is where these hydrocarbons will start acting as a carcinogenic agents. Carcinogenic in a sense, cancer-producing agents. Especially, it directly affects the lung, and so therefore, these hydrocarbons causes the lung cancer. Okay, and the term that I had used was carcinogenic. Right? Now, there is one more point, and that is due to the photochemical. Due to this particular photochemical reactions. Okay, or you can say as due to the photochemical reactivity or the tendency of the hydrocarbons in order to exhibit photochemical reactions, these hydrocarbons will react in order to form photochemical smoke. Okay, so what it is producing over here? It is producing photochemical smoke. Okay, or sometimes it also produces the photochemical oxidants. Alright, so when it produces photochemical oxidants or photochemical smoke, it has a damaging effect on the humans, animals and plants. Okay, so therefore, this is one of the most important things that you need to understand about the hydrocarbons. Right? So let's observe the next one. Final pollutant for this particular video, and that is going to be the oxides of nitrogen. Among various oxides of nitrogen, it is the nitric oxide and the nitrogen dioxide. Remember these two. These two are considered as the most fatal or the dangerous pollutants. Okay, so we have the nitrogen dioxide and nitric oxide. These two pollutants are the most fatal pollutants. Now we need to understand its source. Again, as we speak about these sources, we have the natural sources and the next one is the man-made source again. Okay, so from the natural point of view, it's quite simple as whenever there is a lightning, whenever the lightning strikes, due to the heavier temperature, the atmospheric nitrogen that we have, these atmospheric nitrogens will combine with oxygen in order to form nitric oxide and nitrogen dioxide. Okay, so what we have over here, due to the lightning, okay, what happens, there is a combination of nitrogen and oxygen leading to the formation of nitric oxide and nitrogen dioxide. Okay, now looking forward with the human sources. So why this particular thing forms? The first thing is in the human sources, you will see that in the higher power productions, like power plants. Okay, so in the power plants, what will happen is there is a continuous burning of fuels. Okay, so due to the continuous burning of fuels such as coal, okay, different types of hydrocarbons, a higher temperature is reached. So they have a direct effect on the temperature. So when a higher temperature is reached, almost like a 2000 degrees, then the atmospheric nitrogen that we have, that nitrogen combines with the oxygen. When it combines with the oxygen, it leads to the formation of nitric oxide, and this nitric oxide converts or it reacts further in order to form nitrogen dioxide. Okay, so here is where nitrogen reacts with oxygen at almost like 1500 kelvins to 2000 kelvins in order to give us nitrogen oxide. Okay. Now, nitrogen oxide further reacts with oxygen in order to give nitrogen dioxide. Right? Now, we need to understand about its harmful effects. Now, try to understand that whenever we have the oxides of nitrogen just at a range of 100 ppm, it directly affects the humans, the plants, the animals. Direct effect is on the respiratory system. Okay, so at this particular concentration, it has a direct effect on the respiratory system. Alright. The second thing that you need to understand is that due to the formation of nitric oxide in a heavier amount, due to the natural processes or due to the human processes, it develops or it changes into nitrogen dioxide. Again, that is a fatal one. The third one is that it has a direct effect on the photosynthetic. It has a direct effect on the photosynthetic activities of sensitive plants. It decreases the photosynthetic activities. When the photosynthetic activity is decreased, it has a direct relationship with the leaves and fruits. Photosynthetic activity decreases, leaves start shedding, fruits will start shedding. That means as photosynthetic activities goes down, the leaves and the fruits are going to shed, or shedding of leaves and fruits occur as the photosynthetic activity of the plant is affected because of these oxides of nitrogen. Okay, now the next point is the most devastating point. It is because these particular nitrogen oxide, that's oxides of nitrogen, okay, so when they start reacting, they have a tendency to react with the mixture of gases, due to which they produce a mixture of gas such as PAN, which we have already discussed, that is peroxyacyl nitrate, right? They also react in order with these particular gases to form aldehydes, ozones. They react with these particular things to form these all. The most important thing is these particular oxides of nitrogen, when they react with the gases, they form the most devastating thing, and that is called as it is called as the photochemical smoke. Okay, so these are the devastating effects of the oxides of nitrogen. I hope you have understood various concepts. Do take care, study well. Thank you.